You've never heard of the word logarithm. It's on your calculator. So if you look at a calculator, the button log log, it's on there, but we've never used it. Never had any reason to use it. So today we're going to introduce two things. We're going to introduce what a log is. It's called a logarithm, but you call it log for short. What it is and why we use it and how we use it. Okay? Those are the three things we're going to do. Okay, so first thing, why do we use it? I'll show you why. First thing, you don't have to write this down. This part you don't have to write down. If I wanted to solve this guy for x, what would I do? How would I do that?
Isolate the x.
Get x by itself. So what would I need to do that? Divide both sides by 2, right? We've done that before. If I want to get x by itself here, what would I do? I wouldn't divide this time. What would I do? Take the square root, right? And I get two answers, positive and a negative, right? We've done that before. You guys are good there. Today, we're going to look at something like this. How would I get x by itself here? The answer is we've never dealt with anything like this. The reason we've never dealt with anything like this is because we don't know what a log is. We use a log. That's what that button is for. That button is for when we have cases like this. How do I get x to the ground? If it was on the ground by the 2, I would divide, right? If the x and the 2 were flipped, it would be x squared. Take the square root. I know how to do those. But how do I solve this guy? That's why we use logs. When you have something in the sky that you want to bring down to the ground, when you have an exponent that you want to bring down to the ground, okay? That's why we use it. So what is it? Well, it's an exponent finder. It helps us find exponents. It helps us figure out what that guy up there is, okay? So a logarithm is a special way to ask a specific question. What exponent do I need? What exponent do I need to go from B to A? So you look over here. To go from 2 to 8, what exponent do I need? 3, right? 2 to the third power makes 8. 16 to the negative 1/2 power makes 1/4. Okay? That's what we use logs for. Okay? Now logs and exponents go together. Because if you look, log has an exponent. It's just not in the exponent spot. It's in a different spot. Okay? So how do they go together? This is how. I color-coded it so it would be nice and easy to follow. First thing, exponent has a base. That's the big number. It has an exponent, and then it has an answer. 2 to the third power equals 8. We've done that forever, right? 2 to the third power equals 8. Logs have those same 3 parts. They're just rearranged. First thing, since it's a log, it has to have the word log. So the base, whatever the base was, now becomes a little number, right? It becomes a little number. Still has an exponent, but that's over here now. And then the answer got moved over here. So they're just rearranged in different spots. That's all. They have the same exact parts that an exponent does. 2 to the third power equals 8. Still has a 2, still has a 3, still has an 8. They're just in different spots. Okay, we use logs when we want to know what the exponent is. If we already know what the exponent is, we don't need a log. But today we're going to look at things that we don't know what the exponent is. So we're going to need a log. Exponents. So anytime you need to find an exponent, we use a log. Okay, so one of the big reasons why they use logs are, so in California, what is probably the biggest natural disaster we have that could happen to us? Wildfires, right? If we lived up in the hills, up in the mountains, wildfires would be huge, right? But since we don't live there, we live on the valley ground. What's the We don't have to really worry about wildfires, right? What do we have to more worry about when we're here? Natural disasters.
Is the only thing I can think of.
Earthquakes, right? Earthquakes. We haven't had a big earthquake in a while, right? But earthquakes in California are the big thing, right? In LA, you see like people's homes falling off the edges because the grounds move. Even if there's not a big earthquake, all along the California coast, there's a fault line. It goes from Northern California all the way down to Southern California. It's called the San Andreas Fault. Fault line is a crack. It's a crack in below the ground. So sometimes they move. Sometimes when there's too much pressure, those plates will move. That's called an earthquake, right? We feel it as an earthquake. That's one of the big things we have to worry about in California. We don't have tornadoes. We don't have hurricanes. You know, we don't have to worry about a lot of rain because if we get a lot of rain, great. But we're a valley, so we don't usually get a lot of rain. This year's different, but we have to worry about earthquakes. So earthquakes, how do they measure earthquakes? How do we know if it's a bad earthquake or that wasn't so bad? What's that? Scale, right? There's a scale. Yeah, there's a scale, right? 9.0 earthquake is like earth shattering. If we had a 9.0 earthquake anywhere by us, like the ceiling would probably come down. That's how bad it is, right? 2.0 earthquake. If we had a 2.0 earthquake, you probably wouldn't even feel it because it's pretty mild. Okay? What are those numbers? It's called the Richter scale. That's how they measure it. What are those numbers? Those numbers are exponents. How exponential did you feel it, right? How wide did it? It usually starts in one place and then vibrates, keeps vibrating around that, right? How far did it go out? What was the magnitude of it, right? That's the scale. It's called the Richter scale. That is exponential. That's how they figure it out. They have machines that measure the ground movement. Then the machine calculates what's the exponent. It uses a log. And then it says it was a 4.0 earthquake. It was a 4.2 earthquake. If we had a 4.0 around anywhere around here, we'd feel it. Now, would things fall? No. But we'd feel it. You'd definitely feel it. You'd feel the earth moving, right? So yeah, that's how they measure earthquakes. Okay, using logs. Okay, so that's the big way. And you see it in real life. Okay, so we know what a log is. We know why we use it. The next thing is, how do I use it? How do I go exponent form? These guys, you guys are comfortable with. You guys are comfortable with exponents. You guys know 2 to the third power equals 8. You guys have been doing that for a while, right? Now, what is that going to look like as a log? That's the question. That's the kind of the new part. So I have two things. I have two little tricks to help you go from one to another. So today what they're going to ask you to do is to go from exponent form to log form. And then sometimes they're going to say go from log form to exponent form. So the first one I have is called the loop trick, the loop. This one goes from a log to an exponent. If I start as a log, you're going to use this trick. How do I know if you start as a log? Well, does it say the word log? Yeah, it says the word log there. So I have a log. Okay, so the loop trick. So watch before you do. So the loop trick, how do I move it? How do I get this guy to go from a log to an exponent? Well, first thing you're going to do is you're going to start with the base. You're going to start with the base. And then you're going to loop around till you get to the answer. And then the last thing you're going to do is go over here to the exponent and then loop out. So the first thing you're going to hit is the base. The next thing you're going to hit is the answer. Oops, wait. Wait, that's wrong, right? All right. I printed this out wrong. So we got to change some things. Base and the exponent should be in different spots. So mark this out. Got printed out wrong. So this should be the answer. This should be the exponent. Base is correct. The bottom one's correct, but this one was wrong. So this should be the answer. That should be the exponent. Got printed out wrong. Okay. Okay, so let's do this again. Start with the base. Then we swing over to the exponent. Last thing we do is swing over to the answer. So what we did was we hit the base first. Then we hit the exponent. And then the last thing we hit was the answer. It's called the loop trick. You go in a loop. That will get you from a log to an exponent. Okay? That'll get you from a log to an exponent. How do I go in the opposite direction? So what if I start as an exponent? There is no log, but I need to change it to a log. How do I do that? Well, you use something called the L trick. The L. So the L looks like this. So we started up here. I hit the base first. So when I'm moving to a log, I need the word log. And then you want the base. I hit the base first. Then I hit the answer. Last thing I hit was the exponent. Log. So you start with the word log. Then you hit the base. Then you hit the answer. Then you hit exponent. So it's the log L trick. Okay? Now, I'm going to use those, especially we're going to use the loop trick a lot. I also put it in color code because sometimes that makes more sense. Whatever makes more sense. You don't have to use the loop trick or the L trick. If you're like, you know what, I get it. Base goes from here to there, exponent goes from here to there, answer goes from here to there, then use the color code. Okay? I just have these they're just little tricks. Okay? Okay, so let's go to the other side. So now let's go to actually using these gigs. Let's go to 1A, B, and C. So A, B, and C, which form are they in? Are they in exponent form or are they in log form right now as we speak? Yeah, what's the easy way of telling if it's in a log form? It actually has the word log. Yeah, that's how you can tell. Does it have the word log? Yes, then it's in log form. What we're going to do is we need to change it to one of these guys. So the first thing we're going to do is we're going to change it. Now it's missing a piece though. Which piece is it missing over here? It's missing the exponent part, right? That's the unknown. So for each of these guys, we have to put an equal sign. And then you can put an X, you can put a question mark. We're missing this guy. We're missing the exponent part. That's what we have to solve for. So we have to, so what we're going to do is we're going to change it to an exponent. I'm going to use the loop trick. You can use the color code. I'm going to use the loop trick. So the loop trick says, start with the base. And then go over here to this side, and then finish out back on this side. So 7 to the x power equals 49. What's the missing power? 7 to what power makes 49? 2 squared, right? 2. 2 is the missing part. Next one. It's a log, so I'm going to use the loop trick to change it. So we have 2 to some power equals 32. Well, 2 to the second power makes 4. No. 2 to the third power makes 8. No. 2 to the fourth power makes 16. Almost there. 2 to the fifth power makes 32. So the missing power is 5. Letter C. 4 to some power equals 164. So first of all, it went from 4 to a fraction. So that tells me that what type of number does the power have to be? Negative. It has to be a negative. The only way to go from a number to a fraction is a negative exponent. So to make it negative, it went down to the bottom. And then 4 to what power makes 64? 3, negative 3. 4 to the third power makes 64. But that's not 64. That's 1 over 64. So to flip it to the bottom, it has to be a negative power. Okay. Sometimes you're going to run into logs like number 2. A, B, and C, they don't have a base. They're missing a base. Well, no base, give it a base of 10. Give it a base of 10. So each of these guys are going to have bases of 10. It's called a common log. It's so common that they don't write it. In fact, that's the button you have on your calculator. The button you have on your calculator just says the word log, doesn't have a base with it because it's a common log. Okay? So we're going to rewrite this one with a base of 10. We're going to rewrite this one with a base of 10. We're going to rewrite this one with a base of 10. Just rewrote the problem. I didn't change the form. It's still a log. I didn't do that. I just changed it so that it had a base now. Okay? So I'm going to do the same thing. I need to look for the missing part. The missing part is the exponent. So loop trick. 10 to some power equals 100. 10 to x power equals 100. What's the missing exponent? 2. Do it again. 10 to what power equals 1 over 100? Well, I still have 100. The only difference is it's now on the bottom. So how do I do that? What type of power will move it to the bottom? Negative power. So negative, and then 10 to the second power makes 100. So it's going to be negative 2. Okay. Loop trick, one more time. 10 to what power equals positive 1? What power will always give us positive 1 as an answer? 0. 0. Anything to the 0 power always makes a 1. Anything to the 0 power always gives us a 1. Okay. All right. All right, let's go to the other side now. Same thing. Solve for the missing part. Sometimes it's an exponent, sometimes it's a base, sometimes it's an answer. How do I solve for it? Use the loop trick. Change it to an exponent. This one will say 7 to some power equals 343. This one says x squared equals 36. This one, 7 to the third power equals x. Finish the rest. 7 to what power makes 343? Well, let's see. 7 to the first power makes 7. 7 to the second power makes 49. 7 to the third power makes 343. So the missing power is 3. B, it's not a missing power. I know the power, it's 2. It's a missing number. It's a missing answer. It's missing the base. Sorry, it's missing base. What base? Well, we just talked about this earlier, right? You want to solve? Take the square root of both sides. You get a positive and a -6. So this one we get 2 answers. Either one of those answers will work. The last one, we're just missing a answer. Put that in your calculator. 7 times 7 times 7 makes 343. When you first see them as this, as a log, it's confusing, I know, because today's the first day you've seen a log. But when you look at it like this, it becomes a lot easier. You're like, oh, okay, I know. Find the missing power. Take the square root. Just multiply, right? That's why I converted them to exponents, because exponents, you guys are comfortable with. Take the difficult and make it look like something you're comfortable with, okay? All right, here we go. Same thing. Here, we got the base. I got the exponent. I still know the answer. Loop. So it's going to be 36 to the -1/2 power equals x. So I have to figure out what 36 to the -1/2. Well, it's got a negative power. So how do I make the power from negative to positive? What's the rule for making a power? If a power is negative, what do I do to it to make it positive? Bring it down, yeah. Either move it up or bring it down. This one I got to bring down. So it becomes 1 over 36 to the +1/2 now. Fraction power means I have 1/36 and I'm looking for pairs. So I have 36 and I'm looking for pairs. I don't need to break down 36 because what's the 2 pairs? 6. 6 and 6, right? So the square root is just 6. Move it back in. X equals 1 over 6. Move this guy back in. Okay. Letter B. I'm missing the answer part again. Okay. Change it to a exponent. 729, oops, to the negative 5/6 equals x. Negative power, move it to the bottom. First step. So it becomes 1 over 729 to the 5/6. That means I have 5 power 6 root. (729) to the 5th power. So that means I have 729 times 729 times 729 times 729 times 729. So what I got to do is I got to break down 729 to figure out how many, look for groups of 6. Okay, so over here I'm going to go 729. I believe it's 3 times something. 243 times 3. And then this is 81 times 3. And then 9 times 9. So 729 is 1, 2, 3, 4, 5, 6 threes. 3 to the 6. Well, how many 729s do I have total? 5. So if each one of them has 6, I have 30 threes, right? 3 to the 30th power. So I have 3 times 3 times 3 times 3 times 3 times 3, 30 times. How many groups of 6 do I have?
5.
5. So that means 3 to the 5th can come out. 3 times 3 times 3 times 3 times 3 is 243. Move that guy back in. The hardest part about this, you did last chapter. This is what you did on your last test. You broke down stuff, looked for pairs, put it back in. Negatives move down, negatives move up. That kind of thing you guys did. So the hardest part about what we're doing today, you guys did. That's just review. Once you change it from a log to an exponent, it's just review for you guys, because you guys, that's why we do exponents first. Okay? All right, here we go. Missing the answer, so I'm going to change it to a exponent. So 512 to the 2/3 equals x. Positive power, so I don't have to move it. Leave it like that. There's 2 of them, and I'm looking for groups of 3. break down 512. It's going to be a bunch of 2s. I think it's 9 2s. So I got to break down 512. I believe it's 256 times 2. And then 256 is 128 times 2. And then 64 times 2. And then 64 is 8 times 8. 4 times 2, 4 times 2, 2 times 2, 2 times 2. So 512 has 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. Oh. 8, 9. Should have 9 2s. 9 2s. So since I have 3 of them, or sorry, 2 of them, it's going to have 18 2s. So if I have 18 and I'm looking for groups of 3, how many can I take out? 6. And what is 2 to the 6th? 2 times 2. See, 2 to the 5th is 32. So one more, 64. Move that guy back in. Okay, so I want to give you 2 more problems, quick problems. They're not very long, but practice. I want to give you 2 more practice. So on page 38, 2 more problems. Kind of like the ones we've been doing, I just want to give you some practice so that when you see it tomorrow, you'll hit the ground running. So what is the value of log with a base of 9 of 1? What is the value of log with a base of 5 of the square root of 5? Okay, so what part is missing? Go over here. Which part is missing? The base, the answer, or the exponent? The exponent, right? That's what they want you to find. They want you to find the exponent. So in other words, oops. That's what they want you to find. How do you do that? Loop trick. Do your loop. What's the missing power? 9 to what power makes 1? What power will always make a positive 1? 0. What's the only difference between this guy and this guy? Square root, right? What power gives me a square root? What power will always just give me a square root?
2.
That's squared.
Oh.
You're close. It's actually the opposite of what you just did. Not -2, because it's negative will move it down 1/2. There you go, 1/2. I know what you were saying, Alex. I know what you mean. That's why you were close. 1/2. 1/2 power will give you a square root. Okay. All right. All right. Tomorrow we'll do some practice.